Okay, for number one, a man rowing upstream drops his hat at point M. 30 minutes later, at point N, he notices its loss and rows back. He picks his hat up at a point B, 440 yards below point M. Find the rate of the stream and the total elapsed time. All right, let's take a look, and we'll go to the whiteboard. And I got to draw a picture of this, and the picture is going to be based on the words. And I know there's a river here. I'll just make it a straight river, just number one. So a river looks like this over here. And the water's flowing this way, all right? So a man's rowing upstream, and at point M, he drops his hat. Now, of course, if he drops hat in the water, the hat's going to continue to go downstream, though. But he's rowing upstream, right? Now, 30 minutes later, at point N, this is 30 minutes, by the way, which is a half of an hour. So 30 minutes later, at point N, he notices its loss and rows back. He picks his hat up at a point B, which is 440 yards from M. So I'm going to say B is over here, and it's 440 yards from M. All right. This looks like a tough one, doesn't it? So I'm going to say there's two rates I'm dealing with at this point, and the rate that the boat goes in still water, I'll call that R, and this is the rate of the boat in still water, assuming it's uniform motion, by the way. And you know what? I'm going to call that B. I'm sorry. The reason for that, that's boat. And then R is going to be the rate of the river. All right. Let's take a look. And I know this is going to be a distance equals rate times time problem. All right, so what do we have here? Well, I do know that 400 yards, this is the distance, is equal to the rate of the river, that's R, times the time. I'll call it T. I don't know what that is yet. So I'm going to say the time it takes to get, for the guy to go forward and back is 400 divided by R. And that's the total time, by the way. Now, what do I mean by that? He goes upstream and then comes backstream. So he's going upstream and come backstream, and he gets his hat here. All right, that's the total time then. Well, I got some information about this. I know that total time was a half hour going upstream. That's the part over here. And then he comes back this way. All right, so it's going to be plus some more time. And again, I want to point out what the time backwards is. There's a distance over here. And the distance traveled. Let's talk about the distance traveled. He certainly goes, you know what, it's not 400, it's 440. Let me get my eraser. I just noticed that in the reading of it. Got to get my eraser out now. I'm glad I noticed that too, by the way. And so it's 440. This is the total time, by the way. I did it again. 440 divided by R. R is the rate of the river, by the way, equals, well, he does a half hour upstream. Now, plus the time going downstream. All right, this is going to be another problem for me. And going downstream, what I do know, I know he goes 440 here. That's the distance, by the way. But what's the distance over here going to be? It's going to be, I think I could figure that out, because the distance there, I mean, the distance going upstream, right? It took them 30 minutes to do that, which is a half an hour. So I'm going to say the distance upstream, right, is going to be rate. And the rate is going to be B minus R. Now, the reason for B minus R is he's going upstream. He's got rate in the still water, but the river's working against him. So it's like B minus R, and he's going for a half hour. So let's write that down. The distance here is B minus R over 2. And the distance here is 440. And this is in yards, by the way. So let's write that down. So B minus R over 2 plus 440. That's the distance. Right, that's distance. And I'm looking at that, and he's going downstream. This is going to be the rate downstream. So I'm looking at distance. I want to get time, so I'm going to divide by rate. Well, if he's going downstream, its rate's going to be B plus R downstream. I got an equation now. It looks crazy, doesn't it? I'm going to multiply both sides by 2, because I'm seeing a complex fraction, and I want to get rid of some of this stuff over here. So you can get 880, I'm multiplying by 2, over R. 2 times a half is 1. And over here you can get B plus R. And that's going to be B minus R. And again, I'm multiplying by 2, by the way. So both of those terms on top are going to be multiplied by 2, and that's 880. All right, I got to simplify this. And that's going to be B plus R plus B minus R plus 880. Wow, 880 over R, B plus R. What do you get on top? You get 2B, right? And then the R's disappear. Well, that's good news. And you get 880. Wow, a little bit complicated. Let's divide by 2. I get 440 over R equals B plus 440 over B plus R. All right, let's just get rid of the fraction now. So you get 440 B plus 440R equals BR, or RB, depending, plus 440R. Well, I know this cancels off, which is good news. And then I'm left with something, it looks pretty strange to me. It says 440B minus BR would have to equal to 0. I want to make a note over here that the rates of B and R are going to be greater than 0. And let's put this down. How do I know that? The hat went downstream, so the rate of river is positive. And this guy has made it upstream, by the way. Or he's made it upstream. So that means his rate has to be something, right? He's going to go downstream too, by the way. Let's take a look. I'm going to factor out a B now. And what do you get? 440 minus R. Well, I want to point out the only way this could be true, because B can't be 0, B is not 0, is if R is 0, if R is 440, by the way. Well, I want to go back and read it, because I get the units, I can't remember, but they're talking yards, and I did use hours. So this is yards per hour. All right. So what was our question? Find the rate of the stream. I did that. This is the rate of the stream. I got that part covered. The other thing was total elapsed time. And I want to go back over this. And the elapsed time, this is the total time, by the way. Total time. That's what we started talking about in the beginning. It's total time. Now, what do we have there? 440 divided by R. Well, that seems pretty reasonable because that's just going to be 1. So T, the total time, is going to be 1 hour. Okay, when I write this up, I'm going to give you alternative ways of doing this, by the way. Now, this is the way I would like doing it, but I will give alternative ways of doing it. But the answer here, the rate of the river, is 440 yards per hour. If you're interested, that translates to a more reasonable number, and I'll point out how do you do that. The rate of 440 yards per hour. There's 3 feet in every yard. Put an A there too. Yards are canceling off. And there's 5,280 feet in every mile. And if you do the arithmetic over here, it's a 1/4 mile per hour. All right, that's the rate of the river. Okay, that's done. I think they asked for 2 things. The rate of the river, we got that. And they asked for the total time, which is 1 hour. We're done. Thank you.